Hello all. In this video, we are going to discuss about the linked list data structure and we will implement linked list in Java. First, what is a linked list? A linked list is a linear data structure in which each element points to the next element. In case of arrays, we would need contiguous memory locations, but in case of linked list, we don't need contiguous memory locations because we'll be storing the data dynamically in the runtime. Let's see that with an example. Let's first understand the difference between an array and a linked list. Let's say I have three elements, 1, 2, 3. If I want to store these elements in an array, I would need contiguous memory locations. Let's say the memory address is A1, this is A2, and this is A3. This is in case of array. In case of array, to store these elements, we would need contiguous memory locations. This is A1, A2, A3. So all these are in a sequence. So I'll store 1, 2, and 3. This is how we store elements in an array. For array, we would definitely need the contiguous memory locations to store the elements. When it comes to a linked list, we have the three elements. To store them, we don't need contiguous memory. Let's say this is A1, this is B5, and this is D7. These are memory addresses which are not contiguous. Each and every memory is at some different location. I'll store 1 in this, I'll store 2 in this, and I'll store 3 in this. But as we discussed earlier, in linked list, each element points to the next element. So in order to maintain the sequence, or the order, what we'll do is this element will point to this, and this element will point to this. In this way, we can achieve the sequence in case of linked list. So we don't need a continuous memory location for linked list to store the elements. That is a major difference between array and linked list. Let's see more about a linked list. So in linked list, we call an element as a node. We call it as a node. So as we discussed, each and every element or a node points to the next node, right? So in case of array, we'll just store the value. But when it comes to linked list, we need to store the address of the next node, right? So a node contains two things. If I take this as a node, we'll have data, we'll have the next pointer. We have data and we have the next pointer. In data, we'll store the values whatever we want to store. Let's say we are storing 1. So in case of linked list in a node, data will be 1, and the next pointer, let's say we have 2. So the next pointer will be storing the address of the next element. Let's see that with an example. Now I'll take three elements again, 1, 2, 3. So we have a node in linked list, right? So I'll say it a node. We have data and we have the next pointer, right? So in data, we'll store the data, the 1. Let's say for 2, we'll create a node. For each and every element or the data that we insert into a linked list, we will store that in a form of a node. We have one more node, 2. This is data, this is next. And same in case of 3. This is data, this is next. So now let's say the address over here is, let's say The address of this is A2. For this it is C5. For this it is E6. Right? Now we need to store them sequentially, right? I mean, we need to maintain a sequence, right? After one, we have two, right? We need to know that. So in order to know that, once I've inserted my first element, that is 1, what we'll do is we will store the address of the next element, or we'll just point to the next node. So here we will store C5. So it points to this next node. So here we will store this E6. This points to this. And this is the last element. So for last element, we don't have the next element, right? So here it is null. It will just point to nothing or null. So this is how we store the data. So it stores the address of the next node, address of the next node. So we just call it as storing the address, but it will just point to the next node, point to the next node. And in case of linked list, we will call the first node as head node or root node, head node or root node. So this is how we store the data in linked list. The format, we'll have data, we'll have the next pointer. Done. Now let's see how we can create a node. Let's understand it using code and how we can insert the elements. So we will create a node, right? So each node will have data and next, right? Now, so initially we don't have anything. Initially we don't have anything. So my head node will be null. My head node will be null. We have nothing in our linked list. So I'll add my first element, that is 1. So we will follow some steps to add an element. So if I want to add 1, I'll create a node for that. So I'll say 1, the node is created, and my head will be pointing to the newly created node, that is the first node. And right now we don't have any data, so this will just point to null. Now let's say I want to add 2. So in order to add the next element, we need to add that at the end of the list, right? At the end or at the last element. So right now we only have one element, so we will add that over here. So in order to do that, so I'll create a one node for 2. I've created one node. Now for this, this is data, this is next, right? Now what we'll do is, in order to insert this element, I'll say head dot next equals to this node. Let's say the node of 2. I've created one node and I want to attach that to this linked list which is already existing. I mean, I want to attach that to the end of this list. So in order to do that, what I'll do, I'll just say, already my head is pointing to the first node. I'll just say head dot next. Head dot next means this block. This block is equal to the newly created node with data as 2. So what happens, just create a reference to this node. So the address of this node will be stored over here. And let's say I want to insert one more element, that is 3. I want to insert one more element, that is 3. How can I do that? In order to do that, again, so right now my linked list is like this. I have two elements, 1 and 2. 2 is pointing to null. Now I have to insert a new element, that is 3. In order to do that, we have to reach my last node and I have to make my last node dot next equal to the new node which I'm going to add. So how can we do that? So in order to do that, first we need to traverse till my last node. So right now my last node is this one, that is 2. So in order to reach there, what I'll do, I'll take a pointer. I'll take a pointer called current. So initially it will be pointing to head and I'll say current is equal to current dot next. So it will be pointing to this one. Now, when can I know that the node is the last node? We say a node is a last node if it points to null. So I'll just check whether my current dot next is null or not. If it is null, then I have found my last node, and instead of current dot next being null, I'll just say current dot next equals to the new node which I'm going to insert, this one. Done. So now we have created a reference to the new node. Yeah, null is gone. Now the last node will be pointing to null, obviously, right? So this is how we insert the elements in a linked list. So if I write the steps to insert, first step is I'll take a current pointer that is equal to head. Done. That is equal to head. I have to traverse to the last node. Traverse to the last node. So what is a last node? Last node is nothing but if next equal to null, then that is my last node. I have to traverse the last node and I have to say the last node dot next equals to the new node which I am going to insert. So it will be current dot next, because I'll be changing the value of current, right? I'll be traversing, will be my new node. So we have 3 steps in order to insert an element in linked list. Now let's write the code for this and then we'll also run that. So we have node, right? So I'll define a node. So for defining a node, I'll say class node and my data, int data. I'll just store integer, and we know that we'll be pointing to the next node, right? So the type of that will be node itself, right? Now I'll create a constructor, a parameterized constructor that takes my data and creates a node for me. I'll say this dot data equal to data, and this dot next will be null, obviously, because it is a new node which we are going to create, right? Done. So this is how we write code for a node. We'll have data, we'll have the next. Now let's also write the code for inserting an element. So in order to create, let's see how to create a node for this. So to create a node, I'll just say node. The type is node, and new node is equals to, we'll say new node, and I'll pass the data. Let's say I want to insert 10. I'll pass the data. So this is how we create a new node. Done. Now we know how to create a new node, right? Now let's see how to insert. How to insert. Let me write the data, the code for the new node again. It will be node, new node equals to new node of the data which I want to add. Done. This is the code for creating a new node. Now let's write the insert function. What it takes data. So before writing insert, let's code the new node, or let's code this. So I've created a file, linked list demo.java. So what we'll do, we'll create a class node. Then we'll have data of integer type, and we'll be pointing to the next node. For that we'll say node next, and I'll create a constructor, a parameterized constructor, see equals to data, and this dot next equals to null initially, right? So in order to create a new node, we'll say node equals node, new node equals to new node, and we'll pass the data. So this is how we create a new node, and this is for a node. Done. Now let's get back to the insertion logic. Insertion. Now, so as we have seen above, we have seen an example, right? In order to insert, we have three steps. First step is take a current pointer that points to head, and then traverse till the end of my list, that is till the last node. I have to traverse till the last node, and then I'll insert a new element. So how am I going to insert? I'll just say last element, my last element dot next is new element. That's how we insert, right? So first step is I'll create an I'll just write this. I'll just create a node new node equals to new node, and the data is which we get from the function. Now, so initially my head will be pointing to null, right? My head will be pointing to null. So I'll just check the condition whether my head is pointing to null or not. If it is pointing to null, then we don't have any elements in our linked list. So we have to create a first element, right? So in order to do that, I'll simply say my head is equals to new node. Done. That's it. Let's return. I've inserted my first element. So this is the code to insert the first element or the first node of the linked list, right? Now let's see if already there is an element. If already there is an element, what we have to do is we have to traverse till the end of the linked list. So let's say I already have elements 1, 2. This is my head. So I already have two elements and I have to insert a new one. So to do that, I have to traverse till the last node and add the new one. So to do that, I'll take a current pointer. Why we are taking current? We can directly take head, right? If we take head and if we change the value of head, we will just lose this. So head is very important. Head will point to the starting node, which is the total reference for our linked list. If we lost our head pointer, then we just lost our linked list. In order to preserve and save head node, we will just create a copy. We'll just create a copy. I'll say current is my head. So my head is safe. My head is safe. My linked list is safe. Now I've said my current as head. We have to traverse, right? We have to traverse. I'll take this while loop. Traversing means I'll simply say my current is equals to current dot next. It is moving. It is moving. Current dot next. Current dot next. It just keeps moving. And what is the condition for this while loop? We have to change the current value as current dot next until and unless we reach the last node. How can we find the last node? If the next is null, it's the last node. So the condition in my while loop will be current dot next. If my current dot next is not equal to null, then only I'll move my pointer, the current pointer. If at any point in time, if my current dot next is null, I'll just stop this. I'll just stop this. It means I've reached here. So initially my current is here, current dot next not equal to null. Here it is not equal to null, right? So I'll say current equal to current dot next. I'm here right now. Now current dot next is null, right? So I'll stop here. My current is right now pointing to the last element. Right now pointing to the last element. So already I've created my new element. So I'm going to insert 3. So I've created a new node for 3. I've created a new node for 3. I just have to attach my current dot next is equals to new node. Done. So here I just inserted my new node, that is current dot next. Here current dot next. Done. So this is how, and I'll end this. So this is how we insert an element. We'll create a new node. If it is a head node, then just sorry, if it is if the head is null, then we'll just attach our new node to the head. My head will be pointing to the first node. Done. And if the head is not null, it means already there are some elements present in my linked list. Then I'll take a current pointer. I'll keep traversing till I reach my last element or the last node, and then I'll attach my new node. Done. It is that simple. So this is how we insert. Now let's code this. So we have already created a class for node, right? So I'll write my main class. I'll call it as linked list demo. Done. Okay, let me make it public. I'll write my main function string args. Done. This is my main class. Done. Now let's code for the linked list. Say class linked list, class linked list. So we know that we have something called as head pointer, right? It is the reference for our linked list. It is a complete reference for our linked list. It just points to the initial node because we have each and every node connecting to the next node, right? So if we have the first node, then we obviously have the access to all other nodes, right? So I'll have a head node. So this is an instance variable. So for each and every new linked list that we create, we will have a head pointer initially, which will be pointing to null. So initially we don't have any data, right? So it will be pointing to null. This is just an instance variable. Now I'll create my insert function. Public void insert will take data, So first I'll create my node. New node equals to new. This is the node, right? So node, I'll pass the data. Done. I've created my node. My node is ready. Now the thing is I have to attach that to the existing linked list, or if it is a new one, if we don't have any elements, I'll attach it to my head pointer. How can I check that? If my head is null, head will be null if there is no data in our linked list. I'll simply say head equals to new node and I'll return. Done. I've inserted my first element. Now let's say we already have several elements. Let's say there are one or two elements in our linked list. So this condition will fail, right? So in that case, what we have to do, we have to traverse till the end. So I'll take a current pointer, which will be pointing to head, and I'll take a while loop. In this, I'll say current equals to current dot next. We have to do this till we reach the last node where my next will be pointing to null. So if current dot next not equal to null, I'll keep on traversing. I'll keep on updating the value of current. When we reach the last node, obviously this condition fails. At that point, my current will be pointing to the last node. So simply I'll say my last node dot next, that is current node dot next, is equal to new node. Done. We have inserted element in our linked list. Right. Now let's see how to display the elements. We can't display it. If it is an array, we'll just take a loop. We will take the index and we'll get the element at that index. But when it comes to linked list, it is different. We need to traverse throughout the linked list, and for each and every node, we need to print the data. Now let's see. Let's see how to display the data of a linked list. For that, let me take a linked list. I'll take 3 nodes. Last node will be pointing to null. I'll take 10, 20, and 30. Done. Now let's see how to display them. And my head will be here. Head pointer will always point to the first node, right? Now, in order to print the data, so for first node, I'll say head dot next. But what about the next node? This second node. For that, it will be head dot next dot data, right? So to that, how can I do? If I say head dot data, I'll get 10. Why? Because my head is pointing to the first node, right? If I say head dot data, I'll get 10. Now if I say head dot next, head dot next means head dot next, head dot next means 20. For reference, I'll take A1, C1, D1. So C1 will be here, D1, the address of this will be. So head dot next is C1, that is pointing to this node. So if I say head dot next dot data, I'll get 20. Done. And if I say head dot next, it is pointing to this node. And if I say dot next again, dot next again, it will be pointing to this. And if I say dot data, I'll get 30. Right. So we can even do this. But if we have 100 elements, we just can't keep on writing head dot next dot next dot next dot, right? So to do that, we have to write some logic, right? So let's see. Let me clear this. Yeah, done. Yeah. Now let's call the function as display. I'll take a red color. I'll call the function as display. Done. So again, in order to print this, we'll just say head dot next. So for this, I have to reach here, right? For this, I have to reach here. So what we can do, in case of insertion, we took a current pointer, right? We took current pointer and we kept on traversing. We kept on traversing. We kept on traversing. And we just reached the last node and we inserted the new node, right? In case of display also, we can take a current pointer. I'll say node current equals to head. So my current will be pointing to head initially. Done. Now let's say we don't have any data in our linked list. If we don't have any data, obviously the value of current will be null, right? Here right now the value of current is head, right? So if we don't have any data, the value of the current will be null. So we'll just say no data, no data. I'll just print no data and I'll return. Done. Now let's see how we can traverse or how we can display if we already have some elements. If we already have some elements, let's see this. We have 3 elements, right? So if we already have some elements, obviously we will not get into this condition. We'll get out of this, right? So I'll just take a while loop because we have multiple nodes, right? I have to traverse. Always remember, if I have to traverse, I'll just take a while loop. Let's write the condition later on. I'll just take a while loop. Now what I'll do, let me take nodes here for reference. 1 2 3, right? So what I'll do, my current is right now here, my current is right now here. So I'll print current data, I'll get 1. I'll move my current pointer to here, I'll print current data, I'll get 2. I'll move my current pointer to here, I'll move my current pointer and I'll say current dot data, I'll get 3, right? So again, here what I'll do, initially my current will be pointing to the head node or the first node, right? So I'll just print my current dot data. Done. So for the first node, we will just print this value. Done. Now I have to move to the next node. Simple. I'll just say my current is equals to current dot next. Done. So let's decide the condition later on, but let's see whether we can print the values. So initially my current is at head, right? Initially it is head. So I'll print my current dot data. So I got 10. Next I did current equals to current dot next. So it will shift to this one. My current is pointing to this. Again I'll say current dot data. It will print 2. I'll say current dot next again. It is pointing to 3. Sorry, this is 1, this is 2, and this is 3. Done. So if we don't stop the loop, let's go to the next one. It'll say current equals to current dot next again. So here it is pointing to null, right? So again it'll fail, right? So we have to stop that when we reach our last node. So in this case the condition is little bit different. We'll say current not equal to, sorry, current not equals to null. Why? Initially my current is at head. I printed the data. I have moved the current, I printed the data. Again, my current is here, I printed the data. Done. So at the end, once I reach my last node, when I do this, current equals to current dot next, obviously for the last node, the next is null, right? For the last node, the next is null. So I have to stop. So my while loop will continue until my current is not equal to null, right? After the last node my current value will be null, right? So we don't have any elements. So we iterate, we traverse through this linked list until the current is not equals to null. Done. Now let's see the code implementation for this. So if we implement the display, then we can run this code, we can insert the elements, and we can check whether the elements are inserted correctly or not. Yeah. So now let me write one more function, public void, I'll call it as display, right? So again, we have to take the current pointer. My current is equal to head. My current is equal to head, right? Now, first thing we need to check whether we have the data. If current is equal to null, what's the point of traversing? We don't have any data, right? I'll just say system.out.println no data, no data. The list is, I'll say linked list. Linked list is empty and I'll return. Done. Now this condition is failed. It means we have some data in our linked list. For that, I'll just take a while loop. I'll just take a while loop. Initially, we will be pointing to the first node. So what I'll say current dot data, and then I have to update the current as current dot next. We are traversing, right? Now here the condition is we will keep on traversing until my current is not equal to null. Done. So now we will just print the values, right? So now let's create an instance of our linked list. So my class name is linked list. I'll just say linked list equals to new linked list. Done. I've created an instance. To insert the element, I'll use this insert function. I'll say list dot insert. I'll say 10. Now again, I'll insert one more value. Insert 20. Done. So I've inserted two values. In order to display, I'll just see list dot display. Done. So now let's run this. So I've created an instance of a linked list. When we create an instance of a linked list, obviously this instance variable will be in that instance, right? So my head will be pointing to null initially. So for each and every linked list we create, we'll get a new head because it's an instance variable. We'll get a new head, right? Now let's run this. So here we have inserted two elements, and when I did list dot display, we can see 10 and 20 getting displayed. Let's make the output a little bit better. So I'll just say system dot out dot println linked list data. I'll say linked list data, and here what I'll do is I'll just say, so in order to make it look better, I'll just keep this arrow. Now let's run this. Okay, I missed a semicolon. Okay, let's run this. What's error? Current dot data. Okay, comma is not required. Done. So okay, let me clear it and run again. Now we can see the linked list data is 10. It is pointing to the next 20, and it is pointing to nothing, right? Null. So I'll just display null also. Let me put a space, and I'll say system dot out dot. So if it is end of the list, obviously it will be null, right? So simply display null. Now let's see. So now we can see my linked list data is 10, 20, and the last element is pointing to null. So now if I remove this, let's see, only one element. Now let me remove this element also. Now right now we don't have any data. Okay, let me clear this. Right now we don't have any data, and I'm trying to display. So we can say no data, the linked list is empty, right? Let's try to insert few more elements. Let's dot insert, I'll say something like this. Let's run this. Done. So now we have seen how to insert the elements and how to display the element. So this insert function will insert element at the end of the list, that is end of the linked list. We can even insert it at the start of the linked list also. So we're going to discuss inserting at the start of a linked list and deleting an element at the start of a linked list and at the end of a linked list. We still have three more things which we'll be discussing in next videos. So that are inserting at the start, deleting at the start, and deleting at the end. We'll also be discussing these three functions in the next videos. So that's it for this video. Thank you.